Everything on a Linux system is a file. Linux uses file systems to manage data stored on storage devices. Today we are going to learn how to locate files and folders contained within it. The virtual directory structure in Linux contains a single base directory called the root directory. The root directory lists files in the folders beneath them based on the folder path used to get to them. Here is an example of a Linux file path. Note how Linux uses forward slashes, which is different from Windows' uses of backslashes. And notice how there is no drive letter. The file path itself gives us no clue as to which physical device contains the file. The virtual directory uses mount points to link to the physical devices. In this example, there are two drives being used. Drive 1 is associated with the root of the virtual directory, and Drive 2 is mounted to the virtual directory with the files and folders nested under the /home folder. Thankfully, every distro of Linux structures these in a similar way, thanks to the Linux File System Hierarchy Standard. This standard defines the core folder names and locations. Here are the more common folders defined in the file hierarchy standard. As you can see, it starts from the root, and then underneath the root you have the /bin, /boot, /dev, /etc, /home, /lib, /media, and /mount folders, and then even the /user folder can be further broken down into their own subfolders. Maneuvering around the file system. Thanks to the virtual directory, you don't have to worry about drive letters when moving files from one physical device to another, just the locations within the virtual directory. There are different ways of doing this, the absolute path and the relative path. The absolute path to a folder always starts with the root directory, or slash. As you can see here, it goes /, then it goes from root to home to bow to documents to test and then text. If I was already in the documents folder in this example, I can use the relative path. The relative path would be to do the copy command and then just put the name of the text file, a space, and then /media/USB since that's where I'm copying that. Before assigning a drive a partition to a mount point, it must first be formatted using a file system. Each operating system uses its own file system type. Linux not only has multiple types itself, but it will also support file system types of other operating systems. Some common Linux file system types are the ext3, also called ext3fs. This is a descendant of the original Linux ext file system. It supports files up to 2 terabytes with a total of file system size of 16 terabytes. It supports journaling as well as faster startup and recovery. The ext4, also called ext4fs, is the current version of the original Linux file system. It supports files up to 16 terabytes with a total file system size of 1 EIB. It also supports journaling and utilizes improved performance features. Linux can read data stored in devices formatted for other operating systems. Some of the more common non-Linux file system types are CIFS, the Common Internet File System created by Microsoft, the NFS, which is the Network File System, an open source standard for network storage devices, the NTFS, which is the New Technology File System created by Microsoft, SMB, which is Server Message Block for network storage and interacting with network devices, the XFS, the X file system, provides advanced high-performance features and is still used today. In Linux, to create a file system, you will use the Make File System program, MKFS. You can use the -T option to specify the file system type, then the device file name for the partition you want to format. In this example, you'll use sudo mkfs space -t space ext4 for the file system type, space, and then the drive you're mounted to, space, and then the file system that you want to, space, and then the device file name for the partition you want to format. The mkfs command creates all the index files and tables necessary for the specific file system that you're converting to. File systems can be mounted both manually and automatically. The mount command can be used to display all devices currently mounted and to mount a new device. To mount, simply use the -T option to specify the file system type of the device. So for example, you'd use sudo space mount space -T space ext4 for the file system type, space, then the path to the drive, and then space what you're mounting it to. In this case is USB 1. With the mount command, the device is only attached until the system reboots. If you want to remove a device without rebooting the system, you will use the umount command in either the device name or the mount point directory. Automatically mounting devices. Linux uses the /etc/fstab file for devices that should be mounted to the virtual directory at boot time. Typically, these are permanent storage devices. This table will indicate the options required to mount the device. Let me go to Ubuntu and show you what this looks like real quick. Alright, here I am on my Ubuntu virtual machine, and I'm going to simply do cat/etc/fstab real quick. That is what is contained within my fstab folder on this virtual machine, and it's everything that's needed for boot drives. Notice how it refers to the drive in the UUID number. That way it has the correct drive partition, no matter the order in which they appear during the boot process. You can manually add devices to this folder, but if they are not present next time you boot, there will be a boot error. If you use the encrypt FS file system, these partitions will be mounted to the /etc/crypt tab. You can also view all of the currently mounted devices by viewing the /etc/mtab file. Occasionally, after mounting a file system, you may have to do some maintenance to keep the things running smoothly. There are different tools available to help you monitor disk performance and uses. The EF command displays uses by partition. The U command displays uses by directory, which makes it good for hunting down space hogs. The isostat command gives you real-time information, and the lsblk command gives you current sizes and mount points. In addition to these tools, two directories that can be useful are the /proc/partitions and the /proc/mount folders. They provide information on system partitions and mount points. The /sys/block folder contains separate folders for each mount drive, showing partitions and kernel level stats. Some useful tools for dealing with ext file systems is the blkid command for block devices and deals with storage, the dumpe2fs command, which is block and superblock group information, the e2 label command changes the label on the file system, the resize2fs expands or shrinks the file system, the tune2fs, which modifies file system parameters. Some useful xfs file system tools are the xfs_admin, which displays or changes file system parameters, the xfs_info, which displays information about a mounted file system. These tools are helpful, but if corruption occurs, you will need to use the fsk command. fsk will check the file system to match the index against the actual files. If there are any discrepancies, it will attempt to reconcile and fix the file system. Alright, we are at review question time. First, what file system is the latest version of the original Linux file system? And question number 2 is, what tool do you use to create a new file system on a partition? Pause the video and look back through your notes if you need to. And our answers are, what file system is the latest version of the original Linux file system? The ext4. And what tool do you use to create a new file system on a partition? The mk or make file system command. Thank you everybody for joining me, and please come back later time.